Hey, good morning, everybody. Live from Hannover, we welcome you to our very, very special DIH talks this morning on digital twin technology. And it's also a kind of premiere for us because we are first time doing this from the Hannover, and actually we are also first time as the newly born EDIH. We are first time present in Hannover. It's a national pavilion of Luxembourg. But before we enter into the topic, and before introducing the speakers of this morning, I'd just like to share some information about the platform we are using here. And so now it's big. So just be reminded, first of all, that this session is recorded and it's also available for replay afterwards via our Lux Innovation YouTube channel, but also as part of our platform that we are using this morning. So here easily you have a chat where you, like you know it from any other chat solution as well, where you can place comments and so on. But if you have specific questions to me or to the speakers this morning, please rather put it into the questions section, because this is actually what I'm going to monitor during the time our speakers are speaking. And there is also a poll, but this morning we will really like to concentrate on the content that our three excellent speakers have, and therefore we will spare the poll from this morning. So moving ahead now with the content, and just to show where we are. So we are really at the convention center. We have a special room here that we equipped this morning with our new mobile studio. And actually it's a quite big fair for those that have never been in Hannover. It takes you already quite a while to move from the halls at, for example, entrance north to the east. And as mentioned, we are also present at the Hannover Fair. You find us in Hall 2, and it's actually B40. It's the National Pavilion of Luxembourg that was organized by our friends from the Chambre de Commerce. Now, finally, let me introduce our first speaker, which is actually Jan Bosch from AWS. Welcome, Jan, and thanks for joining us this morning on our session. I know there is a lot of activity at your booth. I have seen it yesterday. It's quite impressive, I have to say. Compliment for that. And just to introduce Jan a little bit, I think you're more than 10 years already with AWS. You were holding different positions, but you're, let's say, you're very much focusing on the digital twin as well as IoT technologies. I hope that's correct.
That's exactly correct. I really have the privilege to work with EMEA customers on in IoT workloads.
Okay. Okay, and so the floor is yours. Let me share the screen again, and then please go ahead. And for the audience, be reminded, please put questions that might come up into the question section.
Okay, so let's start. As Joachim just introduced me, I'm a worldwide go-to-market specialist, but also solution architect, really focusing on IoT workloads on the AWS cloud. So I really have this privilege to work with customers from all sizes in Europe, on all countries, on really IoT workloads in the manufacturing focus. So today I will present a session around delivering business outcomes with digital twins. And what I will talk about is why is the right time for digital twins, the 3 keys to unlock business values. I will talk about 2 customer use cases, and I choose some European customers so that you can relate better to these use cases. And of course, I will talk about partner, because partner in the digital twin space is a very important topic, and partner technologies. So let's start with the first one. So we have a definition of a digital twins. There are many definitions out there, and everybody has a a bit different view or definition of what it is. How we see it at the moment is that we have 4 components here. We have a physical system. We have the digital representation of this physical system, in our case in the cloud. Of course, both are connected. And at the end, the end result is, of course, we want to have a business outcome. What is the special meaning of our definition is also that the digital twin is hydrated by data coming from the physical system. That's one aspect, but also that the life cycle of the digital twin needs to adapt to the physical things over time. So that's a very important aspect, because these assets that are monitored might live for 10 years. So the digital twin needs to adapt to the life cycle of the system. So why digital twins and why now? I think there are 4 factors we identified. The first one is the sensor technology really improved and in the last 10 years. And so ad hoc sensors, but also more and more kind of machines, assets have included sensors, so can provide data that can be included in a digital twin. Of course, connectivity is another aspect that is very important, that moves fast. 2 aspects here. First, connectivity from getting data, for example, from a factory into a cloud, 3G, 5G, local 5G, and other connectivity technology. But also, as AWS, we also have cloud technology that runs at edge, that optimize data transfer between your physical assets, wherever they are in the world, and your digital twin that is living in the cloud. The third part is modeling, and here also 2 different kind of aspects of modeling. Modeling to drive kind of business outcome, which can be simulation, high performance computing, or others, but also modeling, because in digital twins often we also have a visualization of the twin. So it's the spatial computing, it's the digital visualization, it's the 3D visualization aspects that really evolved quickly in the last years. And of course, all this data that is collected by the twin, the cloud resources, the on-demand cloud resources, compute storage resources, really help executing digital twin really at scales at a worldwide level. So what kind of business outcome, when I work with customers, what are the business outcomes that I see often in the last years? Of course, it's around improving asset performance. I think that's a case that a lot of people, customers are looking at the first use case for getting into the digital twin space. Then, of course, enhancing productivity. Productivity also of your operators, of your experts that are on site, and also technicians that are there on site. So this is an important aspect in the performance improvement. Now, a lot of engineering data or engineering input or design input is maybe not on site. So there's a whole kind of business outcome of improving remote experts, using digital twin, in fact, to have remote expertise and looking at the twin, for example, when you're not on site, and doing root cause analysis when you're not on site, and understanding also evolution, predictive maintenance, and other aspects. And of course, one topic that is in all that everybody is looking at is reduction of power consumption, and of course, to reduce carbon footprints. So how can we unlock these business values? So this is a key slide that showcases the typical challenges. First, data is often very siloed on your production sites, on your factories, but also in the IT landscape. We talk about, of course, sensor data, machine data, equipment data, but also manufacturing execution system, ERP system, COS system, where maybe there's documentation living. So we have this kind of siloed data that are living at the edge, but also in the cloud, that we need to kind of get it together. Then the other aspect is the modeling side. We want to create kind of a knowledge graph that represents the twin in the cloud, that takes all these different data sources that come from different locations and creates a uniform view on your on your physical asset. And then the last aspect, because we are all humans and we live in a 3D world, of course, there are also different kind of visualization. Sometimes it's maps, sometimes it's 2D, sometimes it's diagrams. But in the digital twin context, often a 3D visualization, it's an important feature of your twin, because we are just living in a 3D space, and we are good at orientating and navigating in a 3D space. So these are the three kind of ways, in fact, to unlock this business value. So going a little bit on some of the services, so AWS has more than 200 services that you can use, that partner and customer can use to create their solution. Of course, there are databases, there's compute, there's storage. We have several services that are specifically useful in the context of digital twin. And the first one is called AWS IoT Twin Maker. The kind of tenants we had for ByteDance when we designed and created the service was that the data lives already in several different silos. Well, we want to keep the data where it is, but have this uniform view. So that's the first premise we had when we designed the service. We have a whole world and a whole kind of feature set for accurately modeling, in fact, your environment, and aggregating all these data sources in a single comprehensive view on the side. And of course, once we have this model, once we've connected to all these data sources and get them into a cloud environment, it's all the aspect of creating application on top of this knowledge graph, on top of this ontology, and on top of the data sources we are collecting. Could be 3D view, could be mobile apps, or could be web applications. Another service that is often used, and in fact both services work well together, it's a specific data sources. So in a lot of industrial manufacturing use cases, we have OP3 data sources. AWS IoT Sitewise is a service that is optimized to get this equipment data over various different kind of industrial connectors in OP3. But specifically, often we see OP3 data sets, getting it at the edge, buffering it at the edge, and uploading it in a very effective and cost-effective way into the cloud. And of course, doing dashboarding and doing asset modeling on the side. So TwinMake and Sitewise are two services that work well together. Because often the data sources are in OP3. So we have used IoT Sitewise to ingest it into the cloud, and we use on top of this one AWS IoT Twin Maker to take the OP3 equipment data, but also merge it with other data sets, for example, videos, audio, documentations, and maybe process data, or the data that lives not at your factory store, but maybe in third-party systems. So this is a little bit an introduction, services we can offer, the challenges. What I want now is show a little bit more concretely what our customers are building based on these technologies that I just showed in this technology. So I picked up two different customers here. The first one is IDEMIA. They are leaders in identity technologies. So they in fact produce over 1 billion units per year, SIM cards, bank cards, and all of it. In fact, they had a challenge that they wanted to improve responsiveness of their workforce, extend the service lifetime of their robots here. In fact, what they wanted to monitor is these collaborative robots that pick and place these units from one station to the other, and of course, improve quality. So in a prototyping exercise, we're using our prototyping team. In fact, we built in a very short period of time, for 6 weeks, a data ingestion platform we're using Sitewise, a dashboarding capabilities and analytic capabilities to optimize, monitor, and create a central monitoring dashboard for their 6 production sites that are worldwide, separated into different And in fact, they could have been improved by until 5 and 10% the availability on fact of these robots. So the next use case is also French customers. So they are in the logistic and food transportation, especially for cold chain transportations. They are also in 15 European countries. They have 1,500 kind of vehicles, cold vehicles that they are operating. And they have this challenge, and of course, like the cold chain, they can't be interrupted and they need to be alerted and monitored on this side. So they want a continuous integration of data. They want, of course, threshold sensing. So when there is a breach in the cold chain, alerting capabilities and monitoring capabilities. So this is a view, of course, of the digital twin that we created together with them. On the right side, you see the simple dashboard where you see the cold chain, the cooling units, the storage area that has to have a certain temperature, but of course also like energy consumption. And on the left side, you see a digital twin of their building. But also what is important here that we overlay data that comes from these sensors, like the gate door that is not closed, so it's highlighted in red, or maybe a cooling unit that is things, or the room temperature that drops at a certain level. So here we see both the data and also this tree visualization aspect in the web application to monitor their code.
It's not moving? No. Okay.
Going back, of course, all this can only be done with partner technology on the modeling side, on the connector side, on the ingestion side. We have, of course, system integrator that can help you building this project. We have internal teams, and we have technology partner like Siemens and Matterport that I will go to a little bit in detail. One thing we have is Siemens has a great platform for IoT and has one service called Mendix, where we have now an integration. So Mendix is a low-code development platform where now you can integrate the TwinMaker kind of 3D visualization and asset modeling aspects into your model and build your own kind of low-code application aspects. The other partner I wanted to mention is Matterport. Matterport is specialized in creating kind of scans using LiDAR cameras of your things. The challenge is here, often CAD systems are not up to date with the actual reality. So these CAD systems can in fact scan your physical environments and then import it into the twin, and then you can overlay the data on top of it. If you want to see these demos, Siemens or Matterport, you can go to if you are on site, you can go to our booth at the Hall 15 and talk to our partners and customers that kind of demonstrate these demos at our site. So thank you. That was all from my side.
Thank you, Jan. Very interesting, I have to say. Let me just switch off so that we are seen here on screen. So so far we have not received any questions from the audience, but I took some notes. I mean, if I was watching what you were explaining, one of the base questions I always have to say, is because we work a lot in Luxembourg also with smaller and medium-sized companies, would you say digital twin, is it something only for the big players, or is it something applicable for smaller and medium-sized companies as well?
That's a very good question. In fact, the two examples I chose them because they had a use case-based approach. They wanted to experiment with the technology. They wanted to experiment with cloud technology, and then realized at the first step a small use case in these aspects. But also we have customers that have a broader vision that, for example, work with our system integrator on a broader digital twin. Okay. The good thing, cloud is an on-demand pay-as-you-go system, so you can really experiment easily and also without too much investment to see if a digital twin technology can help resolve your business values.
Okay. What would you say, the examples you have shown, what was actually the motivation that they were thinking about digital twin? They could have thought about other things in order to get quality control in place or optimizing processes. Why digital twin, and why is that different from my experience?
So I think I mentioned in one of the value also this remote expertise aspect. So this is one of the aspects, because here you can see in fact and dive into the actual physical environment. Both customers have, like, one is in 15 countries, other has 6 different production sites all over the world. So being in fact from a remote session, an expert being able to in fact dive into the actual values, see it, visualize in a 3D environment. That's one of the aspects that helps here. And of course, there's different data sources. We don't only talk about time series data, equipment data. We talk about documentation. It could be 3D assets. It can be also video streams that can be overlaid. So a twin is often more than just analytic data. It can be all sort of kind of data streams.
Okay, interesting. Thank you. Okay. I mean, I'm encouraging the audience again to raise questions. Otherwise, I continue to. I took down one other specific. You talked about this twin maker and Sitewise, and about all different kind of IoT devices a company might have in their shop floor, for example. Mm-hmm. How do they actually communicate in such a case? I mean, it's a bit more on the technology now, but just for curiosity.
Yeah, so there are multiple ways of connectivity, and I really only showed a very, very small subset of the service we can use. But most of the time, it's a combination of software that runs at the edge, that is controlled, monitored, and operated by the cloud, that has industrial connector to connect to different PLCs, like the Siemens PLC over there. 7 protocols. We see more and more also kind of protocols like MQTT, ITH that are coming, and then uploading it to the cloud. There we have 2 things. I see customers that have real-time use cases where a protocol like MQTT is quite useful, because you can get important data like alarming data in the case of the cold chain. This is something that you want to get directly. There might be other high-frequency data that is only needed for batch analytics. Often there we use protocols that upload it, for example, once an hour for do daily reporting, weekly reporting.
Okay,
so
interesting.
And in fact, the AWS technology stack allows you, in fact, to realize all these different kind of use cases and data ingestion use cases.
Okay, interesting. Now we have also a question from the audience. Actually, it's Daniel Lieberman, one of our good colleagues at the MECO in Luxembourg. He's asking how long it typically takes to get a digital twin up and running.
Yeah. So one of the use cases here, I think, in fact, in 6 weeks, they had the prototype or the POC running. So that can be fast. Of course, there are connectivity is something that needs to be there. So that's one aspect. Also, you need to unlock the data on the equipment side. But small prototypes, that's the idea of Twin Maker. That's why it's called Maker. It's that it's accelerated the creation of a twin. And Sitewise is a service that accelerates the data ingest. So with these 2 services, and with not a lot of developments, you can quickly create a POC and check, in fact, if the expected business value and outcome is things, and then expand as the cloud scales as you need. You start small, you validate where you are, and then you expand to multiple sites. That's exactly how these 2 customers have done.
Okay, very interesting. And then maybe also last question from Daniel, otherwise we run a bit out of time here. I mean, you mentioned already now a few challenges. You see commonalities maybe when it comes to challenges between the different projects you were in?
So that's of course one side. I think when you need to get the data from very remote side where connectivity is maybe not reliable, that's one aspect. It's possible. So we see this, for example, in energy and utility, where you maybe have remote stations that are maybe just 3G or very low things. So there you need to use services that can optimize these uploads and make sure, for example, if the connectivity is not there, it buffers locally and then sends it up when connectivity is there. Okay. So these are often these are aspects that.
Very interesting. Thank you, Jan. I think we stop here, and now we are trying to connect actually to our booth. Let's see if our technology is working here. Thank you very much
for having me.
for joining us today, and I can only recommend to others, really to others that are here at Hannover Fair, to join the booth of AWS. It's quite impressive, and you see also a lot of partner solutions that are running there, and also about IoT and a lot more. Thank you, Jan.
I will be there the whole week.
Thanks again.
Thank you.
So you can see here that we have the pleasure as L-DIH to represent you at the Hannover Messe. Just to give you a bit of perspective of the context, and you will see we moving. There are 6,000 exhibitors, and you have over 200,000 people basically are joining this whole area. So the L-DIH is here present for you. What we do, we look and scout about the technologies. We are present on the national pavilion. You can see it on my back. And we are scouting technology, the latest trends, so that we can replay that back to you. And we bring to you, of course, the right experts and the speakers. So what is new in this edition today? Well, clearly digital transformation is still key. Industry 4.0 is a key topic all across the 20 basically major halls populated with 6,000 exhibitors. We can see the evolution. We just discussed about digital twins. It has raised its bar in terms of usage, use cases, and moved into a real application. You can go and start to see also the first use cases on metaverse. So to give you how that also evolves gradually. Technology is also about everything that is on AI. Is this year a big push into the Hannover Messe and part of a lot of the expressions and the use cases that are now applied to the industry. And last but not least, cybersecurity is still a big topic since, as from 2023, unfortunately, the industry is now the first sector being targeted by cybersecurity before finance and banking. So, which is not exactly the first place you wanted to address. Now, on what is next? Well, the next is definitely everything that is linked to energy management, fuel cell, hydrogen. Of course, the latest 12 months and the crisis with Ukraine and Russia and the energy crisis has put very different light into that topic, and this is why, for the moment, this is a key area. And of course, sustainability, not only natural carbon neutrality, but the whole sustainability side is actually getting into the real, I would say, focus on the industry manufacturer as their strategy. So in the industry of the future, you have not only the digital transformation, you have the whole energy management and the CO2 side. So I'm here with the pleasure to be on the National Pavilion with our colleagues of the L-DIH, and we will continue over this week to continue looking at the trends, the key technology, what can help you in Luxembourg for the one that have not had the possibility to join here in Hannover Messe. So I will see you again in a few moments, but for the moment, back to the studio, as we say in television.
Okay, thank you, Arno, and thanks for the impression straight from our booth, from the National Pavilion of Luxembourg. And I'm here now with Magnus Edholm from Siemens. Welcome, Magnus. Really appreciate that you found the time because you are also a quite busy man at your booth. And again, we will talk about digital twin technology where Siemens can help. And I guess it's better you introduce your bio by yourself.
Absolutely. Thank you very much for having me. Also a pleasure to be part of DIH Luxembourg, definitely. Yes, it's my 22nd Hannover Fair, so I've been here a few times. We are to be found in Hall 9. We have some 4,000 square meters of digitalization, lots of digital twins, lots of partners, lots of things going on there. So it's a very busy week, I must say. But something you look forward to every year.
Cool.
Definitely.
Okay, so let's just start your presentation. And just a second. So it's there. Please go ahead.
Thank you very much. So my role as I'm head of marketing for the digital enterprise, and I will try to see where I'm going to click here to get this thing going. I know talk to you about the digital enterprise, what we're capable of doing. It will align a bit to what we just saw from the Amazon Web Services AWS presentation. Obviously extremely important with everything we do. So we'll start with the movie. So the question, but how? And with that, I mean, how do we pick up speed? How do we accelerate transformation using digitalization as an answer to the challenges with Industry 4.0 and many things with that? And our answer is quite simply to start combining the real and the digital world, because this is a true game changer. And this will give you access to data, because data is what it comes down to. Collecting data, understanding data, and using data for continuous optimization. If you by any chance have the time and possibility to drive by one of our plants, we've got a few, perhaps the one in Bad Neustadt in the northern parts of Bavaria, or in Amberg, also in Bavaria, you will see how we effectively have been able to communicate or combine the real and digital worlds. What I want to say with this is that we don't just talk about digitalization, we actually walk the talk. We drink our own champagne, our own Luxembourg Cremant. Thank you very much. And that is how we do it. And this is to achieve the level of digital quality that we obviously want to bring to the market. So combining the real and digital world. And what you do is you look at the life cycle, design, realize, and optimize. And this for the product, obviously, and also for the production. Ever so often, those two are separated from each other. And in some cases, it makes sense, but ever so often, bringing those two together adds a lot of value, since this enables a flow of data between all stakeholders involved in the development of the product and the production. And the data flowing between the stakeholders could be a bill of material, a bill of process, could be automation stuff, it could be material flow simulation information, it could be energy consumption, gas consumption, everything is available for everyone. And this in order to base decisions on data, making decisions in confidence, because this is what it comes down to if you want to pick up speed. And data also, I'm sure you've seen, we're sitting here in one office and then we have a colleague running around the Luxembourg booth. Everything is connected with everyone. And also here, AWS is probably playing a very important role in making this happening. And so we have a lot of data, infinite amounts of data probably. We do, however, have finite resources, and we've got to be smarter with working with the resources. And this seamless flow of data, I have we can call it the value chain, going from design, simulation, engineering, automation, all the way to services. We call this a horizontal integration. But we also have the very important IT-OT convergence, connecting the top floor with the shop floor, and this enables manufacturing companies to increase transparency through their enterprise. Transparency in regards to what are my machines doing, what quality are we delivering, what batches is just left, in case of perhaps recall action, or just being able to know that what leaves and goes out to our customers will add the value that they're looking for. And data also enables us to track the market, to know what the customers want, because it's a lot about flexibility, making customized solutions. And if you look at car manufacturers, they rarely produce the exact same car more than once. So there's a lot of information in there. And when you have data floating around, you need to have a decent protection. You want to make sure that no one is hacking you, no one is stealing your intellectual property. And for that, we also, as Siemens, offer a multi-layer cybersecurity protection with zero trust principles and everything around it. Because this is the key to expand in those absolutely important ecosystems. I believe all companies need to work closer with each other. You need to be in close contact with your suppliers, your vendors, your customers, and cybersecurity is a fundament for that. And I also truly believe that the digital enterprise, I'm sure your question will be, Joe, afterwards, is that digital enterprise small or big companies, all sizes. So I answer that question now. Obviously,
I need a new question now.
Yes, I know. So this is where it works. For all companies, we have this offering becoming a digital enterprise. And that is a digital enterprise. You can see what's coming here. I'm not sure what slide's coming next. Yes, very important. At this year's Hannover Fair, and probably for all of us around the globe, sustainability, climate change is extremely important and should be on the top of everyone's agenda. And if we look at digitalization, what we always have been doing is working with digitalization to cut time to market, to improve quality, reduce cost. And then we went into the field of resilience, flexibility, adaptability, agility to be faster. And Also now, when we have the situation which we are in with the climate change, we should also work with digitalization to master the energy consumption, to become more efficient with that, driving decarbonization of products and processes, build a circular economy, and of course with that, reuse our resources more efficiently. I think one can say that the situation which we are in regards to climate is something that's actually been driven by the industry, technology. And that also means to me that digitalization, electrification, automation will be a tool to get us out of it. So therefore, I think it's extremely important to work on sustainability, using digitalization, take advantage of the data that we find, analyze it, and use it to be more smart and more efficient. And what we have in order to enable speed, because we need to work fast, we have Siemens Accelerators, our open digital business platform where you find all types of services, software, hardware, partner ecosystems, also here for small, medium, and large companies, everything in there. And one important part of the Siemens Accelerator is Industrial Operations X. Extremely briefly explained, it's connected top floor with the shop floor. We bring essential information technology down to the machines, increasing speed, driving innovation, adaptability, everything. And if you come to us in Hall 9, you will see Industrial Operations X pretty much all over the place, and it's well worth a visit. And I swear to God, I will take you on a tour if you come by. So enough with the theory. I'm going to move into batteries. Why have we chosen batteries as this year's technology carrier? Well, electrification in mobility is changing, it's driving us, and what we will need to do now is to start producing batteries faster, high quality batteries, much sustainably. Because from 2018 to 2030, the demand for batteries will grow 14 times. So with a factor of 14. So batteries will be needed, not only for mobility or transportation, also for the industry, for storage of data, energy, and also tools, probably handheld tools. There's a lot of things being done there. So we need to figure out how we produce and design this battery the best way. And here to the topic, we will use, I'll start a little too soon there. In the design phase, 80% of a product's environmental impact is actually set. This means we got to get smarter here. And we can be smarter by working with a digital twin of the product. And I will show you what I mean by that. If we have a battery, for example, we can start designing it in our software products, NX in this case. We model the cells, we model the modules, we model the carriers. We're simulating how heat is developing in the batteries. We're also developing software in parallel, battery management systems, which are extremely important. We're looking at the vibrations, the sturdiness of the battery. Everything can be checked. And this is important because if you do this in a digital world, you're not using resources. And the simulation solutions that we have at hand are extremely good in doing just this. So this will cut time to market. It will not use too much resources. So go digital is here, of course, extremely important. So our comprehensive digital twin, as you can see on the screen, is covering not just the design and the modeling of a battery pack. We also go upstreams in the chemistry, mixing the slurry which is put on the foils. We are doing mechatronics concept development. So you have mechatronics concept systems, you have mechanical engineering, hitting electrical engineering, we have automation, everything at once. We're working cross disciplines in all of this. And so that's kind of the most comprehensive digital that we have. An example, if you have an electrical vehicle, the charging of the battery can vary from time to time. What we do know, though, is that the first 80% of the battery is being charged rather quickly. The last 20% takes a bit more time, and this due to the development of heat. So we dug into this with a company, EDAC, a German company, and we try to figure out how can we get more cooling fluid into the battery when charging and get the hot fluid out. So working with generative design and topology optimization, we got this rather organic flow splitter developed. And this one is extremely effective. We were able to increase the cooling performance with 22%, and that also in a very short time. So we reduced the development time with 50%, which is the next click. And this thanks to those algorithms working in the software. So now we have a very good product. How do we produce it? And also here, Joe, I think you guessed it, we're going to use the digital twin, this time in the facet of the production. And we're going to step straight into it. I'll show you a movie here, how a mixer is mixing the slurry. This slurry is used on the foil, which is actually being wrapped up in batteries. The machine itself, developed in Mechatronics concept designer, the mechanical components, the electrical components, and also software, or virtual commissioning using virtual controllers with a real PLC code, looking at the material flow through the facility, and eventually we're going to end up in those gigafactories. And I can tell you one thing, those things are huge. I think you can take like 5 or 6 pentagons from Washington and put them in a gigafactory. It will fit. So they're big. And you can just imagine how much. 1 minute left.
1 minute left.
That's not going to work. There's a lot of machines in there collecting data, understanding data, and using data with a digital twin. We have a partner on booth, company Jagenberg, developing slitting machines, which essentially cuts up the foil in the correct width to make those batteries working. And also here we're working very close with simulation solutions. In this case, we have AmiSim, which basically stretches the foil to the perfect length with the correct force. You don't want it to rip because that will be wasting resources. And the IT/OT convergence also here, industrial operations plays an important role. We have standardized automation, standardized interfaces, which obviously also here makes it a joy to buy a machine because you can essentially just plug and produce instead of plug and pray or plug and play, whatever you would like to say. Battery pack robot gripper, also this, you can see all those use cases, by the way, in online. A battery gripper is lifting a battery pack, weighs somewhere between 38 to 42 kilos, pretty heavy stuff. We figured if we can make the gripper lighter go away from aluminium, we can reduce the CO2 footprint, which we have done, and using also here all the simulation solutions available out there. So we managed to also here reduce the time to market with the development, and also been able to go from a big robot to a smaller robot. And smaller robots, Joe, saves energy. Thank you very much. And also here the CO2 reduction, since we don't use aluminium, which are extremely
quite impressive.
Yeah, I can skip after this, but you need to see this industrial metaverse. I'm sure you've heard about it. Here we're working very closely with NVIDIA. So what you see now is actually rendered in NVIDIA. So the machine that was looked at, the slurry mixer, looks like that in the industrial metaverse, able to simulate it. And also here, you might have some of those mixers in your kitchen. This looks kind of delicious, could be a smoothie or something, but don't drink that. It's potentially really lethal. And also here, the assembly process, working with Jack and Jill, our digital colleagues, making sure that the workplace actually isn't harmful to our workers. So lots of manual labor, of course, also needed. And then we go to the real world. Obviously, as Siemens, we've been here for a long time. The company turned 175 last year. The Simatic, as a controller, has 62 or 63 years on the market. So we've been here. So everything you need for a complete automation of any industry, of any size, we are surely in there. Because remember, I said in the beginning, we drink our own Cremant. And also energy manager, and here coming back to what the previous presenter said of using data. And if you want to make sure become more energy efficient, you need to measure the consumption first. And with Mendix, which was also mentioned, we're able to develop dashboards monitoring where data is being consumed, energy being consumed, and this gives us the possibility to cut the energy cost, 40% less power consumed and 40% natural gas consumption. In this day and age, needless to say, this is of utmost importance. Seagreen also, I'm almost done. The carbon footprint inside your company is easy to track. In the supply chain, could be a bit more of a challenge, but with Seagreen, which is based on the Stanium platform, we can make sure we're monitoring the CO2 footprint around the place. And also the last thing being the battery passport. When you travel here, you don't need a passport because you're part of the European Union, but the passport we have will also apply for the batteries. So 2026, the battery passport will be mandatory for all batteries, even the small ones. And this will make it much easier when we come to recycling process, that we can use the information in the battery passport and perhaps work with an artificial intelligence to disassemble the batteries, because today only 5% of the batteries we recycle. We got to get better here. This development needs to go to remove. And that is recyclability by design and using also air automation, because also this is potentially harmful for people. That is how you accelerate transformation. I'm sorry if I took too much time.
That's not a problem. It's quite interesting and very interesting examples, I have to say. We did not receive any question from the audience again.
They didn't have time.
They were carefully listening to what you were saying, but you did something very good for us at the beginning by not knowing, because you mentioned the factory in Amberg, and actually, besides the DIH talks, we have twice a year, we tour around with a bus in Luxembourg normally. This year we will do an exception. Actually, we are inviting our community of manufacturers to join us on a bus for 2 days trip in November. We will actually visit the SPS fair in Nuremberg. The next day we will be in Amberg, and we have an invitation to visit this smart factory as it was built for, if I'm not mistaken, for the PLC production. Correct. As far as I know. Correct. So thanks for the advertisement you did on Amberg, and so our message to our audience: feel invited. More information will become available very soon. When I was watching your presentation and listening to it, you made a clear separation between digital twins on products and production. From your experience, I'm not sure if Siemens is carrying analytics on that. What you see more? You see it more on production, or you see it more on product development, digital twin technology?
Over the years it has changed, but now I see it on both sides, definitely. And the digital twin has got several facets depending on what challenge you're trying to overcome, or what goals you have. So, and we see an acceptance, and I truly believe that if you want to stay on the market and get that speed, you need to start working with digitalization solutions. Digital twin is something that can grow over time. And digitalization as a journey doesn't really have an end stage. It's about a continuous optimization, step by step. Going back to Amber, we started in 1992 by sending a recipe, we called it back in the days. It's essentially a bill of process, what components goes into a PLC. And that recipe described the components. That's how it started. And that's like, oh, this works. Next step will be perhaps a simulation of material through the factory. And so the step-by-step process. The most important part is that you actually start digital transformation. Where do you start? Well, if you have a question, you come to Siemens. We have the consultants able to give you an outlook, create a roadmap, and also support any company of any size and industry on their digital.
Okay, thanks for that answer. Checking again on the questions here, but then allow me another question, because for good reasons you mentioned certainly the sustainability. Also, Arno mentioned it already on energy consumption. Building a digital twin on the production, I would assume you see already also that the equation on energy consumption for the production is also taken into the digital twin, or is that something where I'm just dreaming of? Or
no, it's all there. It's all there. I didn't mention it now, but in my presentation, but also the building automation plays an important role in all of this. You really need to have the air conditioning system running full throttle all the time, or can you turn it on? Can you turn off lights? There's a lot of things in there. The energy consumption. You will have machines that requires heating. To turn them off every time a product leaves is probably not very efficient. You can turn it down a bit. So you can simulate, check that. And in all this, communication plays an important role. And again, you need to collect data, understand the data, and use the data. And then I think you can tackle those challenges and make sure that it all comes together on a collaboration backbone, a platform, so that when you're working with your development and my data that we have, we're intrinsically aware of each other. What changes you make may affect what I need to do. And that's the type of data flow that we need.
Very interesting answer, I have to say. Thanks for that insight. I think I will look again on the questionnaires here from the audience. There's nothing. I would say we stop here because we ran a bit out of time.
I apologize for that.
But it was interesting. Thank you very much for the insights that you have given. And beyond digital twin, I think that, and as we can see now already on the second example, there is actually a lot to gain if, as you said, you start somewhere the journey towards more digitalization. Absolutely. Thank you very much. And we are going to connect again to our hall number 2.
Back onto the Hannover Messe on the floor with the Luxembourg National Park, and with the different, I would say, partners that are here. And they will basically, we're going to see them while I'm walking to reach out to one of the companies that has chosen to really expose its own services into the ecosystem here in Hanover. And it is the company L-DIH. I'm going to reach out now to their booth. As you have in meanwhile, you can see how the National Pavilion is constructed with the different actors along the side. And here am I now with Jeremy Lambert from L-DIH that is going to introduce us the company, also say why they have chosen to be here in Hanover.
Yeah. Hello, thank you for having us here. My name is Jeremy, I'm data scientist and customer success lead in L-DIH. So our mission in L-DIH is actually to bring AI to the hands of industrial manufacturers and simplify seamless interaction between new technologies and their production process. So we want to make them more efficient, so improving their asset health, their process optimization, and really help them to get more with the same assets performing better. So for that, we have a tool that is allowing seamless interaction between data scientists, data engineers, process engineers, operators, and managers to really give an interactive system that gives them everything they need to improve their function process using data and AI.
And you focus really on the industry, and that's why for you the Hannover Messe is a must-go place.
Yeah, exactly. So we focus on manufacturing industry specifically. So the Hannover Messe is a good opportunity for us because we can actually meet some clients that we are not used to see. So some of them are very far away from most people around the world. And it's a good opportunity to also illustrate to new potential customers that are also a big presence here to give them the ability to see how we can help them and hopefully work with them.
Thank you, Jeremy. I mean, you can see the result of activity and soundcheck being performed in other booths, but for us, it's time to leave back the floor to the studio where we're going to know more from L-DIH experience. So back to the studio in Hanover. In the meanwhile, I'll show you still around. Thank you, Jeremy.
You switch me? Thanks, Arno. So I don't know how it was for the audience, but here in the studio, actually, the sound was not super duper, but actually, it's not a problem because I have the founder of L-DIH, one of the founders of L-DIH beside me, Philip Mees. So welcome in our mobile studio, Philip, this morning. And anyway, we are together at the same booth from Luxembourg. So thanks for joining us as well. And maybe you repeat a little bit the introduction of L-DIH because I'm afraid the sound quality was not that super at that moment.
Yeah, sure, Joe. Thank you very much. Indeed, Jeremy is a bit of my digital twin, but it didn't work that well. So I think I'm going to be able to replicate this. So maybe you can access this slide.
Yes, I can, of course.
So we can get started.
Just a second. It's coming now. Et voilà.
Et voilà. Okay, so you see my screen?
Yeah.
Okay, so I'm one of the co-founders and I'm the CEO of L-DIH. And we're a scale-up. We're a tech scale-up. We're based in Capelle in Luxembourg. And that's also why we're hosted on the Luxembourgish booth, so Hall 2, booth 40. We're a Luxembourgish scale-up, but we have customers all over the world. And our customers have 2 or 3 things in common. They're all in manufacturing. So Jeremy mentioned that as well. So 100% of our customers are in manufacturing. They're pretty big names on the screen, but we also have small customers as well. And these customers, they all have one thing in common, is that they all believe and they all use data and artificial intelligence to improve their production processes. And what we at Wizata, what we've done is we've built a digital platform that will enable them to do that. So I'm going to get into that, and I'm going to talk about two things that haven't been mentioned so far and that I think are relevant. I'm going to talk about AI, artificial intelligence, and I'm going to talk about process engineers. Because, if I can click on this.
Yes, sure.
Yeah. Because in industry, basically it's all about the process, okay? It's about optimizing your process, it's about reducing your costs, it's about optimizing your operational excellence, and it's also about keeping your IP, okay? So the process engineer is kind of at the center of that. And the vision we have at Wizata is how do we enable him to use AI as an extra tool to optimize his processes. And the answer to that is to build an environment or a context where he can do that without IT skills and with simple solutions. And this context and this environment is, of course, what we call the digital twin. So indeed, it's collecting the data from different kinds of sources. It can be the assets, the production lines, it can be other systems, it can be weather data, it can be maintenance data. And what we do is we bring all these data into a time series format and we align them to be relevant to the production processes. Okay, imagine you want to improve quality, for instance. Well, the moment you see a defect is not the moment where this defect is produced. Okay, so you have to have a full understanding of your process and digitalize it to be able to create business value. So we're going to talk about the digital twin as a center, as a context, and we're going to show you how a few of our customers have actually used this technology to improve their production processes. So just a little bit of theory, and there's a bit of repetition of what's been said, but it's all about the process. So it's not about creating a 3D copy of an asset. It's about digitalizing and giving context to a process and the data that's related to this process. Okay. Also, a digital twin is an interface. So it has to be a tool that interacts with the human being. You have to be able to have actionable insights. You have to be able to perform actions on the process. It's not just a dashboard that displays multiple information. And it's really a replica. It's a digital replica of your physical process. Okay. So whatever you do in the physical world has to be replicated in the digital world, or whatever you do in the digital world has to be or can be replicated in the physical world. And we'll talk about that, also what that means. Okay. Also, if you want to start working with digital twin technology, you don't have to replace all your existing systems. Okay. This is a layer of intelligence that can come on top of what you have, and you need to plug it in your process data and bring it back into the twin. Okay. And last but not least, the reason why we built the twin and the reason why this twin enables process engineers to use AI to optimize their production dashboard, their processes, is that in industry, what you want to do is you want to harvest knowledge that's specific to your production, and then you want to replicate it and scale it, because you very rarely have one plant. I mean, small companies have one plant, we can do stuff, but the big challenge for large companies is that they can have very smart people, very smart process engineers or data scientists seen in one location, but you need to be able to replicate and scale this knowledge across your production to actually harvest and generate the return on your investment. So enough of the theory. We'll talk a bit about concrete use cases. The first use case is a limestone producer. So worldwide limestone producer, they have 56 plants across the world. And they use, to produce lime, you use a kiln. It's called a kiln. So that's the picture you see there. Basically, it's a massive oven. So it's an oven, it's 80 meters high. It burns 300 tons a day. It's a big machine. Uses a lot of energy, has a lot of inertia also. You can imagine that you don't just flip a switch and you modify a set point and it suddenly responds immediately. And what they really wanted to do is they wanted to find a way to digitalize their production process on their vertical kilns, use AI to pilot these kilns. So pilot the kilns autonomously in closed loop, so take the data, run it through an algorithm, and then feed back and set points into the machine, okay, to stabilize, okay. And to do this, you have to, of course, they save massive amounts of energy, and they have to keep the quality. As you know, in energy, it's always a trade-off. How can I reach my optimal quality while using lesser energy? So they came to us with that, saying, okay, we want to do that in one plant, and then once it works, we want to replicate to our plants. And the way we work and the way we think the best way to build a twin and to for the process engineers is you follow 3 steps. You digitize, so you build a twin, and then what you have to do is you have to add intelligence to your twin, and what we call intelligence, what we built is artificial intelligence, so AI machine learning models. And then you have to provide a way to be able to operate this. So you need to provide an interface for these process engineers to access all the relevant data to optimize their processes and be able to do stuff with it. Because the doing stuff is very important. So I just give you an example here. If you drill down from the twin to one specific section of the process, you have dashboards and you have also let's say, information that's related to process. So yeah, you have monitoring, but you can also have calculated values, and you can also have actionable things you can do to impact your process. So I think the 2 I've highlighted there are predictive maintenance, and we'll talk about that later, because of course you want to know if you have refractory bricks, you want to know when they're going to break, or you need to predict machine failure. And you can also, you have to do simulation. And that's a very important thing in industry is what they call, or what you call what-if scenarios. To be able to simulate scenarios digitally without, actually, they talked about that with Siemens as well, using resources and also limiting risks, okay? So you need to have this tool that provides you with information, and you need to be able to optimize your process and interact directly with your line, okay? That's the famous bi-directional connection between your digital twin and your physical production. And I'll show you another example. This is in another industry that's massively, let's say, uses energy massively and also has huge maintenance costs. So this is a rolling mill. We have a customer in steel, and these rolling mills are very, very big machines. They're submitted to incredible constraints in terms of mobile parts, in terms of friction, in terms of energy use. And here we are in the operate part. So you have the visual of your line or your rolling mill. And the main requirements here was to use AI to optimize energy or to prevent failure. So to reduce time, reduce the life cycle and prevent failures. So what you do, you have to have a very interactive way as a process engineer of selecting, let's say, the relevant sensors or bearings that are relevant to your business case and your use case. And then you run your models, you get your recommendations that can be applied either by the operators or directly into the machine. So this is not science fiction. We're going to talk about that. The AI is not magic. We have built-in solutions that quite quickly allow you to reach these business goals, okay? So energy reduction, anomaly detection is very, very important in industry and rotative equipment. And about the intelligence part, you recall that when I talked about the digital twin as being, let's say, the environment or the place or the context where the process engineer will meet AI and will manage to do it, we need within the twin to build this intelligence, okay? And to build intelligence, you need to provide solutions that allow people to use drag and drop technology or low-code, no-code solutions to build their own models, okay? So sure, you can have a team of data scientists that can do Python and code, but you also need to have prepackaged solutions that you can use and as a process engineer, be able to use to optimize your business processes. So input values, basically, that come from the twin, functions or models, and then output that can be alerts or recommendations or such kinds. Okay. And last but not least, when we talk about business value, and this is very important, you need also to have actionable outputs. So your twin will replicate your process. It will give you an environment where you can act, optimize, and deliver things. but it also can give you insights about what's going on with knowledge. So it will learn from historical data, it will learn from current data inputs and results, and it will provide you with recommendations on how to operate. So in this case, this was, I think it's motors on rotative equipment, and it will tell you, okay, you need to lubricate this machine will break in this time, you will get, these are the maintenance actions you need to perform, okay? So it has to be very interactive and provide value. So a conclusion is really the twin is the place where engineers and AI meet to generate business value. We all agree on that. From a technical perspective, and we talked about it with Amazon, is one of our partners. We need a hybrid mode, so it has to run in the cloud, but we all know that some plants have really bad connectivity, so you need to have a hybrid model with edge. So you have an edge component physically at the plant. You have to have a UX that's easy to use. Okay, so it must not be a massive implementation over months and months with complex trainings. It has to be quite intuitive, and that's important in the way we designed it. It's not limited to large companies. So once again, I answer the question. It's not really a question of the size of the company, it's a question of the size of the problem. So what can we solve, and how can we help companies to solve issues? A small company can digitize an oven. We have an example of peanut roasting. I mean, it's not heavy industry. It's important. These guys, they want to optimize the quality of their peanuts and reduce the energy because they have big ovens. Small company, and they work with us, and they're very happy. And also, it's a good starting point. So you start your journey with a digital twin. You use one process, you digitalize it, you get measurable results, and then you replicate and you scale it. So that's about it for me. It was a bit of the reality check, I think, of this webinar. So if you want to talk about it, you know where to find me. And thanks a lot for being here.
Thanks, Philip. Very interesting. And oops, sorry. And what I really like listening to you now in comparison to the other speakers that are providing platform solutions, here I can really hear the implementation practice. And it's quite interesting to listen to you and the two examples that you have shared. When listening to you, I have to say, I was a bit wondering, I mean, you obviously learned a lot with your team, with your customer, I would even say, when you started the journey implementing a solution based on the digital twin technology. But can you maybe disclose a little bit, what was the initial motivation of your clients to start the project?
Well, they want Industry 4.0 is everywhere. Everybody knows you have to digitalize, but not everybody knows how to start. Right? And so usually we get in the room because, okay, they want to use AI. Okay, AI is super important. We need to use AI. And so what we usually do is we guide them with the business case. So we say, okay, guys, you have everyday stuff you want to solve. How can we help you solve it? So we try to define with them what the quickest win can be with a measurable ROI on a specific process. So that's really the motivation is money always. And it's about reducing costs and keeping your IP. That's what it's about. So the motivation is really trying and being successful. So I think it's part of the journey now for any company in the industry.
Okay, very interesting. I mean, in most cases, you mentioned the energy argument. Was it also part of the considerations right at the beginning, or it slipped in?
No, it slipped. The first cases were around quality. The very first cases we had were around quality, reducing defect rate. Then we had a lot of predictive maintenance, and of course, since last year, energy is a major concern. And energy in the beginning, in our projects, was like a collateral effect. So it was easy to move because by stabilizing or optimizing a process, usually you use less energy for certain machinery. And then the collateral effect, this is interesting, maybe they dig deeper, and now it's a request.
Okay.
Mainly around gas.
Are you allowed to share any numbers on energy saving?
I can say one thing. If you use the energy savings in gas, so these big kilns, they save about 2.5%. Which is very big amounts because they use massive amounts of energy.
Okay, very interesting. Just looking at the question section, we have nothing from our audience. Maybe then, because we are already a bit over time, actually by 11 minutes, but I mean, those harsh environments, I mean, both examples were really harsh environments. I mean, coming from the automation side, I could imagine to get the data was quite challenging.
That's a good question. It's there are multiple answers to that. I mean, for the moment, I think industry is trying to standardize. We talked about OPC. We're trying to standardize the ability to collect the data. You talk to IT, but they're not the people buying, so they have to be involved in the project. So, but the data is there, and that's something that's very specific to industry. The data is there. Industry has been collecting data for years, but they're doing simple things with it. They're doing monitoring, they're doing alerting, they're doing SCADA. You know, that's where you are. So the data is there, but with this data, you can do so much more, and that's why we plug on the AI component.
Okay, very interesting, Philippe. Unfortunately, I have to say, I could continue with tons of questions, I have to say, but for the sake of time, I think we have to get to an end. Thank you very much for sharing those insights. Really, from an implementation side, I find that very, very interesting and hopefully also encouraging for some of the companies that are hopefully listening today that have not started yet on the journey towards a digital twin or something even lower. But as it was mentioned several times today, and actually this is also in reflection of the discussions we are having as the L-DIH, you have to start, and you should start somewhere. Even if you go small steps, which is anyway recommended, you will gain results. We see it everywhere.
Yeah. Exactly.
Thanks again.
Thanks again. Thanks everybody.
Okay, sharing something quickly and short. I mean, first of all, thanks to all those active speakers we have today, Jan, Magnus, Philip, and also Jeremy sharing and connecting from the booth, as well as Arno, our director of the Digital Innovation Hub. So thanks again for that. Actually, I was trying to share something which doesn't work now. It's not okay. Here we are. Sorry for that. Just all ready to move ahead with what we have planned for the next months when it comes to our DIH talks, which is actually the episode 2, which will all be on additive manufacturing and 3D printing. And we are already in the process of lining up the speakers, and I can already say it will be quite interesting, and all the solutions, all the experience sharing that we will have on that day is coming out of Luxembourg. Quite interesting. The next bigger and larger event where we are also participating from the DIH is our Smart Manufacturing Week, which is at the very beginning of June. And it will be at the Lux Expo. And as you see from the numbers last year, typically here we have a high attendance rate. More than 250 people joined us last year. And beside all the sharing and keynotes that we will have during those 2 days, it's certainly a very nice opportunity on networking. And everybody who has been there last year, can confirm that. So thank you very much for those that joined us today. Was also for us a quite exciting exercise to do that here live from Hannover. And with that experience, I think we can already say we will do that more often, being also with clients that have implemented something and start to broadcast really being on site. And that will certainly lift up the quality and the interest, hopefully, on this webinar, because it's all about inspiring, informing you about existing solutions, partners that are on the market, OEMs like AWS and Siemens that we have heard today on their different platforms. So thanks again for joining us today, and see you soon in Luxembourg again. Ciao.